Okay, in these first 10 problems, you're going to be comparing rational numbers. And so when you're given a fraction, you need to change the fraction to a decimal in order to compare the numbers. And number one, you're comparing the fraction 5/8 to the decimal negative 0.6 or negative 6/10. Now in this case, if we had a number line and this was 0, wouldn't you agree that 5/8 is going to be to the right of 0 and negative 6/10 is to the left of 0? Right? So whatever number is further to the right on the number line would be greater. And so we could put 5/8 over here to the right of 0 because it's a positive number. And we could put negative 6/10 to the left of 0 because it's a negative number. And so since 5/8 is further to the right on the number line, it is greater. Okay, so we need the Pac-Man or the alligator mouth eating the bigger number. So we would say 5/8 is greater than negative 6/10. And this is always the case when comparing a positive number to a negative number. All the positive numbers are greater than the negative numbers, since the positive numbers are to the right of the negative numbers. They are further to the right on the number line and therefore greater. Number two, you have the same situation as far as comparing a positive number to a negative number. And number three, you're comparing two negative numbers. So change this fraction to a decimal and then compare these two. And number four, let's do this one together. So we have this decimal, negative 12 hundredths, and this fraction, negative 1/9. Let's make this fraction a decimal. So top number goes inside the division bracket and bottom number goes outside. I know that 9 cannot go into 1, so I have to add placeholder zeros after the decimal so I can continue dividing. But where is the decimal on the 1? I don't see it, so it's after the last digit that I do see. It's right there. And then add placeholder zeros afterwards. My decimal comes straight up into the quotient. It's right there. We already said 9 cannot go into 1. It goes in 0 times. So I look at the first two digits, the 1 and the 0. So the number 10. Can 9 go into 10? Yes, it can. It goes in 1 time because 1 times 9 is 9. Once I subtract 10 minus 9, I got 1. Bring down the next digit. 9 goes into 10 1 time. 1 times 9 is 9. I subtract and get 1. Got to add a placeholder 0 so I can bring it down. And what do you see that keeps happening? I keep getting 10 right here, and 9 always goes into 10 1 time. And so up here in my decimal, I'm going to have 0.1111111 and on and on and on forever and ever and ever, right? This is what we're going to call a repeating decimal. And so it would be 0.1, or in this case, negative 0.1, since we're taking the fraction negative 1/9 to a decimal. So when comparing these two, I have negative 0.12, and I could say negative 0.11. I really only need two digits after the decimal on this when taking a fraction to a decimal, because I'm comparing basically this digit in the hundreds place to that digit in the hundreds place. So on this number line, this vertical number line, which number is further up on the vertical number line? Let's say this is 0 right here. This would be, let's call this 0.10, negative 0.10. Below that, I would have negative 0.11. Then I would have negative 0.12. Okay, so when looking at it this way, which number is further up on the number line? That would be this number right here, negative 0.11, which is this fraction. Okay, so negative 0.12 is less than negative 1/9. Okay, you try 5, 6, 7. You're comparing two positive numbers. Same thing in number 8. Number 9, two negative numbers. So be careful here. Make this fraction 7/8 a decimal, and then compare the two. Number 10, make this fraction 5/12 a decimal. So 5 divided by 12. Okay, so you're going to have to add placeholder zeros after the decimal so you can continue dividing. Decimal will come straight up into your answer. Okay, so you can finish that one on your own. The rest of these, you're looking at a number line and you're trying to figure out where a certain point is at. So let's look at number 13. Where is point C located? Okay, so here's 0. right here. Here's 1. So the first thing when given a number line is to figure out how much is each tick mark worth. So from 0 to 1, how many jumps does that take? It takes 1, 2, 3. It takes 4 jumps. Okay, so if it takes 4 jumps to get from 0 to 1, how much is each jump worth? Well, we could say it's worth 1/4, right? I got 0, then 1/4, then 2/4 or 1/2, then 3/4, then 4/4, which is 1. But as you can see, some of these are written in decimal form. Okay, so I have to be able to comfortably go from fraction to decimal given whatever answer solutions are in the list. So I want to know where's point C located. Well, we said that's 1/4, 2/4, 3/4. Looks like C is at 3/4. So do you see a 3/4 in the list? Yes, that one right there. Okay, one more. Let's do number 16. Which point is located at negative 1.45? So let's figure out how far is it from negative 1 to negative 2, or at least how many jumps does it take? It takes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It takes 10 jumps to get from negative 1 to negative 2. So that tells me that each jump must be worth 1/10. So I would say negative 1, negative 1.1, negative 1.2, negative 1.3, and so on until I get to negative 2. I want the point at negative 1.45. So negative 1.1, negative 1.2, negative 1.3, negative 1.4, and a half more. So this is negative 1.45, right? It's in between negative 1.4. This is, let's say, that point right there is negative 1.4. This one right here we know is negative 1.5. And so in between those two numbers would be negative 1.45. So that is point C, and negative 1.45.